Notes 9.3 focus on the reactions between acids and bases. Now that we're comfortable with what constitutes something as being an acid and what makes something a base, let's look at what happens when acids and bases react. So the reaction between an acid and a base is known as a neutralization reaction. Okay, they are called neutralization reactions because the products of an acid-base reaction are always going to be the same. They are always going to be water and salt. Okay, so we think of water as being a neutral substance, and so since acids and bases always react to produce water and salt, that is where their name, neutralization reaction, occurs. Okay, so the products of an acid-base reaction will always be the same, H2O representing the water and some type of salt. Remember, a salt is really referring to any ionic compound or any substance where we have a positively charged cation and a negatively charged anion. A neutralization reaction is going to work very similarly to a double displacement reaction. So if we take a look at our example here, we have HNO3, which at this point we should be able to identify as being an acid because of that hydrogen starting in front, and we have NaOH, which we should recognize as being a base because it ends in that hydroxide. When this reaction occurs, the acidic hydrogen in my acid and the OH from my base are going to combine. Okay, when they do, they form H2O. And so another way of thinking of H2O is by thinking about it as being HOH. That first hydrogen here comes from the acid, the OH comes from the base. And so the water is being formed from what's in red, the hydrogen from the HNO3 and the OH from the base. My salt in this case then is being formed from whatever's left over. So if I look back at my original reaction, I'm left with the anion NO3 and the cation Na. So the salt that I make in this case is sodium nitrate. Now when we combine our salt, we want to remember our rules for writing formulas, remembering that the positive ion is always first, so Na plus, and my negative ion is second. And if I look up the charge of nitrate, it's -1. So when they combine in a 1-to-1 ratio, giving me NaNO3. Okay, we have to make sure we balance double displacement reactions as well, or these neutralization reactions, and in this case, our reaction is balanced. So an acid-base reaction is always going to produce H2O and a salt. Now let's take a look. Here I have the reaction between H2SO4, also known as sulfuric acid, and LiOH, lithium hydroxide. Again, we recognize the H2SO4 as being an acid and the LiOH as being a base. Once we've identified a neutralization reaction as occurring, the first thing we can do is just automatically write down H2O, since the water is forming from the combination of the hydrogen from the acid and the hydroxide from the base. My next product then, which is going to be my salt, is going to be produced by what's left over. So my positive ion is lithium, my anion is sulfate, SO4, and if I look at the charges, lithium is +1, sulfate is -2, and so when they combine, the salt that I end up with is Li2SO4. So this neutralization reaction produced water and the salt lithium sulfate, or Li2SO4. The last thing we have to do is balance this equation, and we should be getting pretty good at balancing. Okay, to balance it, we're going to balance the lithiums first by putting a 2 there, and then remember our rules for combustion reactions. We said balance carbon, then hydrogen, then oxygen. We want to do the same thing for these reactions. Okay, we're going to balance hydrogen and then our oxygen. So I put that 2 there. Okay, by adding the 2 in front of the lithium hydroxide, it gives me 2 hydrogens in this compound, plus the 2 hydrogens over here, so there's a total of 4 hydrogens, So I can account for that by putting a 2 in front of the water. That also gives me 2 oxygens, and on the left-hand side I have 2 oxygens. So here is my completed balanced equation. So when we see an acid-base reacting, we want to make sure we write H2O or water as one of our products, and then pay attention to what's left over to form our salt, remembering our crisscross method for balancing charges and adding coefficients to balance the equation.